Hello students, welcome to Want to Come. In continuation with stoichiometry, today in this video I will share or discuss about volume to volume relationship or volume to volume stoichiometry between gaseous substances which are present in both reactants and the products in a chemical equation, balanced chemical equation. Because the substances are gaseous, so the volume is the important factor which play an important role here for the solving different types of numerical problems. As we know, there are certain laws like your LUSSAC, Avogadro's, and your Boyle's law, Charles' law, and even your gas equation. All these law deal with your gaseous substances. So while solving problems, we may need or come across with some of these laws, as we have discussed the gas equation when we are discussing mass volume relationship in my previous videos. Let's discuss a very simple chemical equation where this Gay-Lussac's law can be explained in a simplified way. We have to balance this. So this is the balanced chemical equation. So as per Gay-Lussac's, there is a simple relationship exists between the volumes of the reactants and the products. This is 2 volumes of hydrogen. When react with 1 volume of oxygen, it will give 2 volume of water vapor. So the simple ratio between the hydrogen and oxygen is 2:1 here. One more equation, like if we'll take one example of acetylene. When it reacts with oxygen or burnt in oxygen, it will give carbon dioxide and water. If we will balance it, we will get this. So as per the Gay-Lussac's, this is 2 volume, this is 5 volume, it will give 4 volume of carbon dioxide. And again, if we will go for this Avogadro's hypothesis, we will come to know this 2 volumes of hydrogen will react with 1 volume. That means 2 volume means it will occupy 2 into 22.4 liters of volume, whereas the oxygen will occupy 22.4 liters, because this is 1 mole, this is your 2 moles. In that way, all these gases laws are interrelated to each other, and we can come to know many more fact of these laws when we are or while we are solving the numericals. So let's start with a very simple problem. What volume of propane is burnt for every 200 cm cube of oxygen in the reaction to give carbon dioxide and water? So we need to first write the balanced chemical equation as per your rules of stoichiometry. So I will write your propane, and it will react with your oxygen to give carbon dioxide and your water vapor. All are in gaseous. We need here carbon dioxide volume. So first we need to balance this one. So we will balance this. So 3, and this would be your 4. So this is balanced. Now this is 1 volume as per Gay-Lussac's. This is 5 volumes of your oxygen. This would be your 3 volumes of your carbon dioxide, and this would be your 4 volumes of water vapor, isn't it? So from this valence equation, it is clear that for every 5 volumes of oxygen, 1 volume of propane is burnt, isn't it? So as per the question, we have 200 cm cube of oxygen, isn't it? So I have written for every 5 volume of oxygen, 1 volume of propane is burnt. So as per our question, for 200 cm cube of oxygen, or for every 200 cm cube of oxygen, what is the volume of propane? So this would be your 40 cm cube of propane is burnt. Let us move to the next problem. If 8 liters of hydrogen is mixed with 7.2 liters of chlorine and are exploded, what will be the composition of the volume of the resulting mixture? If you see that this problem will tell you about one more term, that is your limiting reagent or reactant. So as per this balanced chemical reaction, hydrogen reacts with chlorine to give HCl. So this is a one volume, and this would be your 2 volumes of hydrogen chloride. So here 1 volume of chlorine reacts with 1 volume of hydrogen to give 2 volumes of hydrogen chloride. So we can find out for 7.2 liters of chlorine, we will get your 7.2 liter of hydrogen, isn't it? But here 8 liters are there, so we need to subtract and we will get here 0.8 liters of hydrogen. So 0.8 liters of your hydrogen is left unreacted. So volume of HCl formed would be the twice of this 7.2, and it would be 14.4 liters. So as per our problem, we need to find out the resulting gaseous mixture, isn't it? So resulting gaseous mixture would be 14.4 liters of your hydrogen chloride and 0.8 liter of unreacted hydrogen gas. So the reactant which is completely used up in the reaction is known as your limiting reagent or reactant. Here chlorine is the limiting reagent and it is completely used up. Let's move to the next problem. It is a very interesting problem. Ammonia is oxidized to nitric oxide in presence of a catalyst and 36 liter of the reactants are utilized. Then write the balanced chemical equation and what volume of nitric oxide would be produced at the same temperature and pressure. Let us write the balanced chemical equation. Ammonia plus oxygen would give nitric oxide plus water. Let's balance this one. This will be 4, 5. This is your 4 ammonia. That means it is clear that 4 volumes of ammonia reacts with 5 volumes of oxygen to give 4 volumes of nitric oxide, isn't it? So the ratio of reacting ammonia with the oxygen is 4:5. 4 parts of ammonia reacts with 5 parts of your oxygen to give nitric oxide. Why I told the term ratio? Because here the total volume of reactants has been given, that is your 36 liter. So 4 parts and 5 parts both would be your 9 parts. Total 9 parts is your 36 liter. So for 1 part per part is equal to 36 divided by your 9, which is coming your 4 liter. So for 4 volume for ammonia, 4 volume of ammonia would be 4 parts, or 4 into 4 is equal to 16 liter of ammonia. Similarly your oxygen, but here we want to calculate for nitric oxide, isn't it? So it is simple. So this is also 4 volume, that means 16 liters of nitric oxide would be obtained from 36 liters of the reactants. So this is the final answer for this problem. Here are some problems based on volume to volume relationship. You please try to solve these problems. Hope you have understood the concept. Thanks for watching this video.